Good morning, ladies and gentlemen. It's 9:45 a.m. on a Wednesday, April 14th, and I'm going to be talking about logarithms. Okay, so this is Unit 6, Day 1, and so let's get started here. Oh, where's my notes? Hold on a second. Uno momento, por favor. There we go. Just so, almost knocked my coffee off the table. All right, here we go. So, let's graph this equation right here. Okay, so this is an exponential function here. Okay, and so it's asking us to graph this guy. So the easiest way to do that, okay, is to plug it into your y equals. Go to your table and get some values that we can utilize to put on the graph. Okay, and that's about all that's going to fit there. So let's graph those bad boys. All right, so -2, right there, -1, right there, 1, 2, 4, 8, and we're no longer talking about sequences. And so we're going to draw a line through all of those. Okay? Now, this next thing is telling us to graph, even though there's really no numbers there, it's pretty straightforward on what it's asking us to do. It's asking us to graph the inverse of f of x. Okay? That's what that stands for. So, if you recall, okay, in order to find the inverse of either utilizing the equation or when you're just given the data points, like we have here, okay, what did we do with the data points? We just switched the x and y. Same thing we did with the, or at least in this case, we switched the x and y values when we're utilizing the equation, right? We switched the x and y variables. But when we're actually given the data points, what we're, the inverse, what they're really doing is you're just switching the x and y values. So let's just go ahead and do that. Okay, and now let's graph this guy. I'm going to pick out a different color. I'm going hot pink. All right, so 0.25, we're at -2. At 0.5, we're at -1. At 1, we're at 0. 2, we're at 1. 4, we're at 2. And 8, we're at 3. And again, there's our graph of the inverse of f of x. Okay? Now, you're probably wondering, why is it that we are doing this? Well, it just so happens that the inverse of an exponential function is the definition of a logarithm. So the definition of a logarithm is the inverse, come on, the inverse, there we go, Mr. Penn, of an exponential function. Okay? So that's all a logarithm is. So in this case, this guy right here, if we were actually to write the equation of this, f at -1 of x is equal to the log of 2x. Okay? And I'll explain more what that guy over here means, okay, and how to write these guys. But anyway, okay, that is the equation of that inverse function, which happens to be the definition of our logarithm. All right, so anyway, heading down here, okay, here is a quick representation on how it is you sort of switch between exponential equations and logarithm equations, okay? And so it's very important that you know how to utilize this because it will help you solve problems. And, well, just like when we were going from negative exponents to, rational numbers and, going from exponents that have, 3/2 and changing them to radical form, okay? This sort of thing is important as well, right? Being able to go from logs to exponential back and forth will help you be able to solve these guys. All right, so that's the kind of the important part about being able to switch these. It just, you utilize it in order to solve these problems. Okay. So anyway, it's asking us to rewrite the exponential equation as log equations. Okay. So here's how we do that. All right, this number right here. Okay, it's considered your base, right? And we should know that when we're multiplying with exponents, right? We know just that 3 is our base, okay? So in all of these, we're all going to change these, and we're going to put log here first. Okay? That's your first step. Then, our base is going to be all of these numbers right here. Okay, so this will be a 3, this will be a 12, this will be a 9, and this will be a 25. Okay? And then we just sort of flip-flop these numbers. Okay? So that number on the outside goes in the parenthesis here. I don't know what is up with my pen today, but come on, man. And then the exponent goes on the outside. So again, this moves in here. Exponent goes on the outside. This moves inside here, 1/9. Exponent goes on the outside. Okay? And lastly, 125 here. Exponent goes on the outside. Okay? And so that is how you interchange these guys. Now, I think it's a little more difficult going from exponential equations to log equations. I think it's a little easier going back the other direction. Okay, going back the other direction, all I do is I just sort of switch these numbers back, and now we have the same equation we had over here, right? Cross that out, boom. Now you got 2 to the third is equal to 8, which makes sense, right? We know that is a true fact. All right, so I think going the other direction is a lot easier. It's just a little weird going from exponential to log equations. Okay, so once you get the process going back the other direction, you start to get better with these. Okay, so anyway, let's go down and go the other direction. Okay, so now we're given the logs. Okay, and we want to switch it back to exponential equations. Okay, so in this case, we start with our base. So you're going to grab the base for all of these. Okay, so 5 and 4. Right, those are our bases here. This guy right here. Right, and then we just sort of flip-flop these numbers, right? So we switch these guys right here. So this comes up here, 5 and 32. And again, it's a lot easier going this direction because we kind of know what numbers we need, right? I mean, we definitely know 32 to the 5th power doesn't equal 2. We know that 5 to the 2nd power doesn't equal 32. And we know that 2 to the 32nd power doesn't equal 5. There's only one representation that makes sense. And it's this one right here, right? So I think, like I said, going the other direction makes it a little easier. But anyway, so we bring down the base, 5, bring over the exponent. 5 to the 0 power is always 1. Okay? 1/2 raised to the -1 power, always equal to 2. And 4 raised to the 2nd power will equal 16. Okay? All right. So now, that's going from exponential to logs and back the other direction. And so if you look in part 3 here, we're missing some stuff that we have in part 2. More importantly, our equal sign and something after it, right? So how in the world do we solve these? Now, you can use this trick. I think it makes much easier in my mind when I do it like this. So I'm going to put a equals x on all of these. And I'll explain why I do that. Okay? And so doing what we just did up above, okay, I'm going to sort of put these back into exponential form here. Okay, so what I'm going to say is 3, switch the x and the 81, so 3 to the x power is equal 81. Okay, but we can actually solve this, all right? Hopefully knowing our, using our mathematical skills here, right? 3 to what power is equal to 81? Well, you can either do trial or error, or if you know the 3 to the 4th power is equal to 81, then this is equal to 4. Let's go over here. Okay, 5 to what power equals 25? Well, it's got to be squared. 2 raised to what power equals 64? I believe that's a 6, right? That should be, yep. X is equal to 6. Okay? Those ones are a little bit easier, right? Now we're going to get into some more difficult ones, okay? So 9 to what power equals 3, okay? Might not seem obvious at first, but remember, anything raised to the 1/2 power is like taking the square root. So the square root of 9, or 9 to the 1/2 power, is equal to 3. Over here, 1/2 raised to the x power is equal to 8. Okay, first we've got to take into consideration that we're going from a fraction to a, well, we're going from a smaller number, a smaller fraction, to a much larger number, right? We don't have any numbers in the denominator, right, other than, well, a 1. So, anyway, so what's going to happen here is this guy's actually going to need to be flipped, right? It's going to need to be multiplied by a negative number. And more importantly, what negative number will work? -3, right? And if you want to think about that, 2 to what power equals 8? Well, that's the third power, but I want to get this 2 back in the numerator, so it has to be negative. Okay? And then finally, 5 to what power equals 1/25? Again, we need this to go from a number, where 5 is in the numerator, to where 5 is located in the denominator. So more importantly, this is going to have to be, again, raised to a negative number, and that negative number is going to have to be -2. Okay? All right. So it says evaluate the following. Okay? Now, notice the difference between what we have here in part 4 and what we've had up here all along so far, right? At least in 2 and 3. Okay? There's something missing, right? And it's actually this number right here, right? We don't see a base, right? We don't have a base here, okay? And so what that means is anytime you don't see that, we have to assume that the base is 10. Let me write this in a different color here, okay? So it stands out a little better, okay? The base is 10 if isn't given. Okay, so common logs is pretty much what your calculator uses, right? So if you look down in your bottom left corner area, right, you'll see log, right? If you hit log, and if you hit 10, right, log 10, it's going to tell you the answer is 1. Log of 1, it's going to tell us our answer is 0. Okay, log of 0.01, we're getting a -2, and then log of 1,000, or 10,000, sorry, I'm getting a answer of 4. Okay, now where am I getting those, right? Where are those coming from? Okay, so let's put some things in there, all right, to make it look a little more familiar. Okay, let's say you don't remember that these are all 10. Okay, or you maybe just like putting that in there just to remind yourself. Okay, so I'm going to put 10 in there, and I'll just remember what those answers were, right? Because I'm going to show you how they came up with them. Okay, so I'm going back to what I did before, up in the one above, and I'm going to put that x there. Okay, because I know my base is 10. Okay, so then we just rewrite it like we did. 10 to what power equals 10? Well, x is equal to 1. 10 to what power equals 1? Well, x must be equal to 0. 10 to what power is equal to 0.01, or, let me write it, write it so it might look a little more familiar, 1/100. Well, that's going to be x is equal to -2. And 10 to what power is equal to 10,000? Well, that's when x is equal to 4. Okay, and so that's how they came up with those. But just know that, common logs is what your calculator does. Now, there's a way to sort of adjust the base, I think, in your calculator, but we won't be doing that. Okay, it involves a lot of work, and then you got to go back and rechange it. So the way we're going to be solving logs is just utilizing these properties going from exponential to log and vice versa. Okay? And so the last part, okay, natural log. What is a natural log? Well, a natural log, okay, is a log that has a base of e. What is e? Well, read below, right? The number e is a famous irrational number and is one of the most important numbers in mathematics. Okay? Facts. The first few digits are this nice long number that continues to go on. So it's very similar to your, your pi number, right? It just goes on. Now, how this guy came up with this really large number, I don't know. But it's often called Euler's number after Leonard Euler, and hence the letter E. And it has important uses in compound interest, which we did not see. We didn't talk about this, but you ever go in finance or business, you'll see things, especially when you're talking about loans and stuff like that. You'll hear compound interest and stuff like that. So that's where this number appears quite a bit, and also it appears a lot in calculus. Okay? So, anyway, but these are kind of easy to solve, right? All you have to do, okay, is you must use your calculator, right? Because, yeah, you just have to. So, right below log, L-O-G, on the left side of your calculator, you'll see this Ln. Click it. Click Ln, and then you're just going to put that 3 inside there. And it says round to the nearest hundredth. This is going to be 1.1. Okay, how about the natural log of 0.05? That's going to be a negative 2.99. We're just going to round that up. That'll be a negative 3. And the natural log of 1 is just going to be 0, which should make sense, right? Because if our base is e, and let's say I had that, use my last trick up there, I put that x up there. So e to what power equals 1? Well, x would have to be 0, right? So, anyway, I'll put up an answer key for this. So hopefully, those of you that are watching this, you are, able to utilize this and understand it a little better, or maybe you missed class and you're using it to get caught up. But anyway, any questions on this stuff, please bring it to class.